different algorithms that we'll describe in this course, they will have parameters that can make them more flexible or more rigid. Now, we haven't actually seen many of those examples, but one example that we did talk through is decision trees. So for decision trees, we have a pruning algorithm, right? So we can either train the whole decision tree or we can post-prune it to a certain number of, to contain fewer nodes. So if you think of the number of nodes that are left in the tree after pruning as a parameter, it kind of defines, it sort of serves as a knob that you can turn left or right? You could prune more aggressively or less aggressively. If you prune more aggressively, you can end up with fewer nodes, shorter, stubbier trees, and those stubbier trees are going to be more rigid. They will not be able to fit the patterns quite so easily as longer trees. And if you don't prune, you'll end up with trees that can fit data to arbitrarily, to an arbitrary degree of accuracy. They'll fit whatever pattern they see. Right? So this number of nodes is effectively a knob that you can turn left or right. Now, the reason that you need knobs like that and classifiers is because different data sets, different tasks that you do, they require predictors of different flexibility. So, and whether you need a flexible or a rigid predictor depends on many factors. It depends on how complicated the task is. So if the task is simple, usually you want to prefer a more rigid model, a model with fewer, say a decision tree with fewer nodes. If it's highly complicated, then you will probably need a more flexible model, a tree with more nodes. And it also depends on how much data you have. So if you have only a small amount of training data, you should prefer less flexible models, because with a small amount of training data, there is a high chance that you're going to overfit. And rigid models don't overfit quite as much as flexible models. So you want to have knobs like that allow you to take the same decision tree and make it either more flexible or less flexible. And thankfully, knobs like that exist in pretty much all the classifiers that we'll talk about. So in decision trees, it's how aggressively you do the pruning. In naive Bayes, you can put limits on variances, or you can mess around with the smoothing for the Bernoulli models, and that will make the classifier more rigid or more flexible. With nearest neighbors, it's the number of neighbors we consider, so we'll talk about that in a couple of lectures. With support vector machines, there are specific parameters that influence the smoothness or the rigidity of the classifier. So those knobs, good things to have.